This is January 2015, this is paper 2, and this is question number 5. Liquid helium boils at 4.2 Kelvin. Convert 4.2 Kelvin to a temperature in Celsius. The way I remember it is by using 0 Kelvin is minus 273 Celsius. So to get from Kelvin to Celsius, all we do is take away 273. So we're going to take away 273 from 4.2, and we get this number. And they would also accept minus 269, 268.95, because the actual value is 0 Kelvin equals 273.15 Celsius. But 273 is absolutely fine. Liquid helium boils to form helium gas. State 2 ways in which the arrangement and motion of the molecules change as the helium becomes a gas. So they move faster, because they're a gas now, so they have to move faster. They are further apart, because they're a gas. And they move freely. Move freely about each other. Any one of those two would get you those 2 marks. Any 2 of those 2. The average kinetic energy of the molecules in a helium gas depends on its Kelvin temperature. Sketch a graph on the axis below to show this relationship. It should be a straight line with a positive slope aimed at the origin. So something like that. 2 marks. It's got to go through the origin, straight line with a positive slope. Because as the average kinetic energy goes up, so does the temperature in Kelvin. Right. Some air is trapped in a narrow glass tube so the pressure remains constant. Describe how this apparatus could be used to investigate the relationship between the temperature and the volume of air at constant pressure. You may add to your diagram to help the answer. Biomantic, we have some answers. So what we've got is this, we've got this column of trapped air, and it's trapped by this liquid, and it's at a constant pressure. And we need that if we're just going to look at the relationship between temperature and volume. And this is our narrow glass tube. So first thing we need to do is we need something to measure the temperature with. And then we're going to need something to measure the volume or the length, because we can work out the volume from that. Then we're going to have to find some way of varying the temperature of this column of air, and then we're going to measure how much bigger it gets. So we're going to measure that diameter of the volume of this column, and we're going to get a range of values, and then we're going to graph them to see what that is like. Of course, we're going to need repeats as well. Basically, they're asking for a quick description of a method. How would you use it? Well, I would vary the temperature, I would measure the volume, I would take lots of results, I would plot them, and then that's how I would get the relationship between temperature and volume at a constant pressure. And that is question number 4.